Homework number 1. So in addition to the problems that you find in your homework, be sure you can name the 3 main subatomic particles and identify where they are. So we have protons and neutrons. Protons are positively charged, neutrons are neutral, and they're found in the nucleus. We also have electrons. They're negatively charged, and they're found orbiting outside of the nucleus. The subatomic particles are responsible for making isotopes and ions. Neutrons are responsible for making isotopes, and electrons are responsible for making ions. You will also need to identify the SI units of length, mass, and temperature. For length, that is the meter. For mass, it is the kilogram. And for temperature, that is Kelvin. So question number 1, what place value would a volume of liquid measured in this graduated cylinder be recorded? Well, this graduated cylinder is divided into milliliters. We have 50, 60, 70, and in between them we have 10 little hash marks. So each one of these little graduations is 1 milliliter. Now, because we read all that we can read and then we estimate one more, that means that this graduated cylinder would be read to the 10th place. Number 2, what is the answer for the following calculation using the correct significant figures? Well, to use the correct significant figures, we have to do what's in the parentheses first. So we're going to subtract 1.249 and 0.0234, and we'll get a value. And that value, let's see if I can write it down here, is 1.2256. But we need to be careful with that, because we need to make sure that we are maintaining appropriate significant digits. 1.249. Now, when we subtract, I'm just going to write this value down here so that I have it. When we subtract, we need to make sure that our answer is not more precise than the least precise number that we started with. So here we have the 10th place, we have the 100th place, we have the 1000th place. And that is as precise as this can get. So we have to round, and we'll round then to the 1000th place. So we look at this 5, we look next door, and we would have to round that to 1.226. Now we can multiply this by 139.37. And when I do that, I get 170.86762. But that's too many significant digits. We had 4 significant digits in this value, and we have 5 significant digits here. So we must round our answer to 4 significant digits. So I've underlined 4, and I look next door. So this would be recorded as 170.8. Number 3, an object with a mass of 1.194 kilograms and a density of 2.75 grams per centimeters cubed has these measurements. So we are asked to find what the height of the object is. Well, this is going to be a lot of manipulating our density equations. So if we start with, what does density mean? Well, density is going to be mass over volume. Well, we're told what our mass is. Now, because our mass is in kilograms, but our density is in grams, I'm going to convert that mass into grams. So there are 1,000 grams in a kilogram, so 0.194 kilograms is equal to 194 grams. Notice when I convert those units, I have 3 significant digits in my kilograms, I have 3 significant digits in my grams. So I'm going to insert that mass here, 194 grams. Volume, I don't know yet, but I am told the density. And that density is 2.75 grams per centimeter cubed. Now from here, I can calculate the volume. So I multiply both sides by volume, and I get 2.75. That's going to be grams per centimeter cubed times volume is equal to 194 grams. Now I divide both sides by 2.75. And when I do that, I get a volume. I'm going to write it up here. Volume is then going to be equal to 70.5 5, 4, 5, and that repeats. And that is centimeters cubed. Now I wrote that up there because I need to go gather some more information here. And what I need to do now is recognize how to find the volume of a regular object. So a regular object, if we have like a cube, and perhaps the object should say it's a cube. So if we have a rectangular solid, say, and we have 27.8 millimeters on this side, and we have 38.1 millimeters on this side, the question is, what is this length here? Well, if we have the volume, it's length times width times height. But because we're working in centimeters cubed for our volume, we need to convert each of these lengths to centimeters as well. There are 10 millimeters in 1 centimeter. So 27.8 millimeters is 2.78 centimeters. So that is the value that I need to use here. So if I'm going to take my length times my width in centimeters times the height that I don't know yet, is going to be equal to 70.545, and that's centimeters cubed, and I left that value in my calculator. And I'm actually going to divide both sides by 2.78, and then divide both sides by 3.81. That gives me a height of 6.66 centimeters. It says to record the height in millimeters. So I'm going to record 66.6 millimeters for that height. Number 4, identify the following items for an isotope with the atomic number 16, mass number 34. With an atomic number of 16, that means we have 16 protons and we're working with sulfur. So we have 16 protons. I'm just going to fill this in. This is sulfur. And the element symbol is S, and that's a capital S. Now, when we have a mass number of 34, that means that is the number of protons plus neutrons. So if I take mass number and subtract atomic number, I'll get the number of neutrons, which is 18. Now, because we're just dealing with an isotope and it doesn't say an ion, the number of protons is equal to the number of electrons. So that's 16. Number 5, copper is made from 2 isotopes given to you here. Given copper's atomic weight, what is the percent abundance of each isotope? Well, I have it written out here, and it might be sloppy, but at least it's written out. So the abundance of one of our isotopes is going to be X, and the other one is going to be 1 minus X, because when we add them together, we should get 100% abundance. So now we just work a little bit of algebra. So 62.9296X plus, and I'm going to distribute this around, 64.9278 minus 64.9278x, and that's going to be equal to 63.546. We combine our like terms, and it's okay that I have a negative, so I'm going to 62.9296 minus 64.9278. I'm combining my x terms. 1.9982x is going to be equal to, I'm going to take this number here and subtract it from both sides. So I have 63.546 minus 64.9278, and I get a negative 1.3818. See, the negative's okay. It'll all disappear in a minute. I divide both sides by a negative 1.9982, and I get my x value is equal to 6915. I'm going to give you more digits to 2. So this is the abundance. Now, I have 5 sig figs in, I have 6 sig figs there. I have 6 sig figs in each of my numbers, so I'm going to have 6 sig figs, 1, 2, 3, 4, 5, 6. But I needed this to be a percent. So x being copper 63, that's going to be 69.1522%. And then my copper 65 is going to be either 100 minus this percent or 1 minus this, however you want to think about it. Either way is fine. But it's going to be 30.848%. So those values go here. If you ended up rounding, that's okay. If you rounded to like the I want to say the 100th place, that would be okay. So those values go here. Remember, I do manually grade all assignments. If a 44.8 gram rhodium sample contains how many rhodium atoms? Well, rhodium is RH, and this is a great question because it requires you to know how to use the periodic table. Rhodium is right here in the middle. So its atomic mass is 102.91. You also need to remember, or you need to learn how to use dimensional analysis. So 99% of the time in here, when you see grams, you will likely be converting it into moles. So this calculation will then convert our grams into moles, but that wasn't the question. The question was, how many rhodium atoms are there? So I need to use Avogadro's number, 6.02 times 10 to the 23rd atoms per 1 mole. And while you're here, make sure this is formatted well. And this is the work to do this calculation. So I multiply across the top, 44.8 times 1 times 6.02 times 10 to the 23rd. And then I divide that by 102.91. And the value I get is 2.62 times 10 to the 23rd atoms of rhodium. Now again, make sure that you formatted this correctly. If you're not going to use the subscript, use the caret symbol like this, because 10 to the 23rd is not the same as 1023. So make sure you do format it correctly. Write the full electron configuration for a neutral atom of vanadium. Vanadium is right here on the periodic table. That is row 4. So I know through row 3 that we are full. So I'm just going to start typing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then I'm in the transition metals. And because I'm in the transition metals, I know I'm in my 3D. So I count over and I'm in the third column of that D block. So it is 3D3. Now I'm just going to take a moment and format this appropriately because these electrons should be shown as superscripts. That would be the proper way to do it. Number 8, we're going to identify the subshell in which the electrons with the following quantum numbers are found. These quantum numbers are found at the end of my lesson. It's not something I really want you to spend too much time on. I'd much prefer that you spent time on the electron configurations. But those of you who are studying for things like the MCAT, this might come up. I don't know. So I threw it in there anyway. Now, when we have our principal energy level, our principal energy level is the first number when we are writing our electron configuration. So I'm just going to go down, since N is the principal energy level, just fill those in. Now, the L is the orbital number. 0 is S, 1 is P, 2 is D, 3 is F. Now, L1, I just said, was P. So these would be 3D, 4F, and 2P. Now, you should also be able to answer how many orbitals are in each principal energy level. Let's draw that out briefly, just to review. So your principal energy levels basically tell you how many orbitals, how many subshells they have. And then the periodic table will tell you how many orbitals. So the 1s subshell, that has 1 orbital. 2, the principal energy level 2 has an S and it has 3 p's. Each one of those p's is an orbital, so that has 4 orbitals. The 3 has an S, it has 3 p's, and it has 5 d's. So that's 5 plus 4, that has 9 orbitals. That will hold a total of 18 electrons. Remember, each orbital will hold 2 electrons. So the 1s will hold 2. The second principal energy level will hold a total of 8 electrons. The third principal energy level will hold a total of 18. So that's what I mean by that comment at the end.